Assalamu alaikum everyone. I hope you people are fine, and I hope you are also studying at home. Maybe you have done also the homework. Last time I asked some question for homework, and one of the student he was asking if you can solve this one more question. So now I am solving one more question. So that is question number 5. Find the unit tangent vector of the following curves. So if you remember the previous lecture, we already know how to find unit tangent vector. So you know the formula. So formula for unit tangent vector is t is equal to v over v magnitude. So it means we have to find the velocity vector v, and then we have to find the magnitude of that vector, and then we divide. So that will be your unit tangent vector. So here your curve RT is given as so we are solving the third part of the question number 5. So your RT is given as Ti plus 2 over 3 t power 3 by 2 j minus 2 power 3 k. Now the velocity is first derivative of the position vector, so dr over dt. So that is equal to, the derivative of t is 1. The derivative of 2 power 3 by 2 is 3 by 2. 2 by 3 is multiply, and then t power 3 by 2 minus 1. N t n minus 1 formula. And minus 2 power 3 is our number, so the derivative of number will be 0. So if you simplify this, so this will be I plus t power half, because this 2 cancel, this 3 cancel, so 3 by 2 minus 2, so this will be half j, and this will be 0. So it means this will be I plus t half j, or you can write I plus t square root, because the half value is of square root. So I plus t square root j. Now if you find the velocity magnitude, so v magnitude, you know how to find. So here what is written 1, so 1 square plus here is t square root whole square and then whole square root, and this will be 1 plus this square and square root will cancel, it will be 1 plus t. So this is your v magnitude. So therefore your unit tangent vector is v over v magnitude. So v is this given I plus t square root j divided by v magnitude, which is 1 plus t square root. Now 1 plus t square root you can divide with this here 1 over this, plus with the t square root over 1 plus t square root j. So this is your unit tangent vector. It's very simple. If you have done the homework, so that's very good. If you have not done the homework, you can solve now, but you must try at home. And now for today the new topic is curvature. So I will straight move to the question. So it is question number 6 in the practice problem sheet number 3. The question is, find the curvature for the following space curve. So I am solving the first part, and the rest will be your homework. So first part, your position vector RT is given as a cosine Ti plus a sine Tj plus b Tk, where a and b, they are any real number and they are greater than 0. For curvature, the formula is k, we denote curvature with k, so it equal to 1 over v magnitude, so v is your velocity, and then dt over dt magnitude. This, what is this t? This t is your unit tangent vector. So it means for curvature, first you will find unit tangent vector, and then you will take derivative with respect to t, and then you will take magnitude of this, and then multiply with 1 over v magnitude. So everything you already know. You already know how to find velocity. You already know how to find magnitude of the velocity vector. You already know how to find unit tangent vector. Now the only new thing is you have to find the derivative of the unit tangent vector, and then you have to take magnitude of this. So it's very simple. Now first we can find the velocity. So it is first derivative of the position vector. So it means if I find the derivative of this RT with respect to t, so here a cosine t, so derivative of this will be, derivative of cosine t is minus sine t, so this will be a into minus sine ti, plus, and derivative of sine t, it will be a cosine t, and here is b Tk, so the derivative of t will be 1, so it will be only b, so bk. Now, so your velocity is, if I take this minus right outside, so it will be minus a sine t plus a cosine t and plus bk. Now I can find the magnitude of this velocity vector. So this will, I already know how to find the magnitude. So it is v1 square plus v2 square plus v3 square and then square root. So it means here your v1 is this, v2 is this, and v3 is this. So we write minus a sine t whole square plus a cosine t whole square plus v square. If I take minus a sine t whole square, so it will be a square sine square t, because minus it is power even, so then it become plus. So it will be a sine square t plus a cosine square t plus b square. And now from here I can take a square common, mushtarak. So then it will be sine square t plus cosine square t, and the formula sine square t plus cosine square t, it will be 1. So it will be a square 1 plus b square. So if I simplify, so this will be a square plus b square and then square root. So this is your v magnitude. And now a unit tangent vector, the formula, it is t is equal to v over v magnitude. So we already know what is v. So our v was this, and our v magnitude is this. So we simply divide v and divided by v magnitude, and then this you can write with all separate, with I component, with j component, with k component. So or you can, because this is constant, you can write at the end, it's up to you. So here now I have to find for curvature, I have to find derivative of the unit tangent vector with respect to t. So it means d over dt. So this is your t, this all is your t, unit tangent vector. So I will write derivative of this with respect to t. And now this is constant, you can write outside. So only you have to write derivative of sine t. So this is derivative of sine is cosine, derivative of cosine is minus sine, and then derivative of b, this is constant. So derivative, it will be 0. So now, so if you can take magnitude of this dt over dt magnitude, so it will be, because this was a constant number, so you can write outside 1 over a square plus b square whole magnitude. And then here you can write magnitude of this. So this will be minus a cosine t whole square plus minus a sine t whole square and plus 0 square and then whole square root. So this will be a square plus b square, and this will be a square cosine square t plus a square sine square t, and this will be 1 over a square plus b square. So here you can take a square common. So this will be cosine square plus sine square t. So this will be 1, and so it will be a square square root over a square plus b square. So your magnitude of unit tangent vector with after finding the derivative, it is because this square will cancel with this, so it will be a over a square plus b square whole square root. Therefore, curvature of the given curve is k is equal to 1 over v magnitude dt over dt magnitude. So 1 over v magnitude, you already know, it is a square plus b square square root, multiply with dt over dt magnitude, it is a over a square plus b square magnitude. And now this a square plus b square, this also a square plus b square square root, this also square root. So it means here is power 1, here is also power 1, so it will become power 2. And now this square and this square root will cancel, so it will be a over a square plus b square. So this is your curvature. It's very simple. So please try to solve other question at home. And now we can start our new chapter, which is about partial derivative. Now it means now we will move to the practice sheet number 4. So I will share with you practice sheet number 4. So directly I will solve some question from practice sheet number 4. So first question is about limit. Find the limit of the following function. You already studied limit in your calculus 2 course, so it is similar, calculus 1 course, sorry. It is similar to that, but now it is here only the difference is it is multivariable calculus, because previously you are taking only say limit x goes to some number, but here now there is multivariable, so here x and y both involved. So it means we will write also limit with respect to x and limit with respect to y. So we write x y goes to 3 4, it means x goes to 3 and y approaches to 4. So your function f of x y is given as x square plus y square minus 1 square root. So the idea is same what you have done in calculus 1. So you will directly substitute the value if there is no problem. So if it means we can put the value of x as 3, we can substitute the value of y as 4. So it will be 3 square plus 4 square and minus 1 whole square root. If you simplify this, you will get 24. So there is no problem at all. Similarly, we can solve the second one more question. So if limit x y goes to 0, 0, cosine of x square plus y square over x plus y plus 1. So I can put the value of x as 0, the value of y as 0 here. So it is x 0, y 0, then x is 0, y 0. If I simplify this, it will be cosine 0 by 1, and you know 0 by 1 is 0 and cosine 0 is 1. Again, very simple. Next, another example, limit xy goes to 1, 1, and x is not equal to 1. Why x is not equal to 1? Because if I put here 1, so if I put the value of x1, it will become undefined. You know, if I put value of both x1, 1, 1, so if x is 1, y is 1, so this will be 1, this will be 1, here will be this, so 1 1 cancel, here minus 2 plus 2, this will cancel, 1 minus 1, so it becomes 0 by 0, and you know this is indeterminate form. So if there is indeterminate form, it means you have to come from another way. So maybe sometime you have to factorize, sometime you have to rationalize, sometime you have to do some other thing. So in our case, for example, here x y minus y, I can take if you put directly, I said value x1 y1, you will get 0 by 0. So that is why now 0 by 0 is no answer. So it means it is indeterminate form. It means you have to determine by another way. So what is the other way? Other way, as I said, sometimes you have to factorize, sometimes you have to rationalize, sometimes you have to do some other thing. So here, for example, what we can do, x y minus y, I can take here y common, so it will be x minus 1, and from here I can take minus 2 common, so then it will be x minus 1, because here I take minus also common, so then this minus plus, it will become minus. Now you can see here x minus 1 is common in both, and then what is left? Y minus 2. So then this x minus 1 and x1 minus 1 will cancel, because x is not equal to 1, x is approaching to 1, so this can cancel. So then it will be limit xy goes to 1, 1, 1, so 1, 1, and then only this cancel, we are left with y minus 2. Now you can substitute the value of x as 1, but there is no x, so you can put only the value of y1, so 1 minus 2, so now the answer is minus 1. So in this way we can solve. Similarly, if we have limit p goes to pi 0 3, it means if no, what is p? P in this case is x y z. So your, it means any point. So your point x is say the x y z. So x goes to pi, y goes to 0, and z goes to 3. You can see here now 3 variable z, x, y involved. So that is why we are writing here p. You can also write x, y, z goes to pi 0 3. So it means I can write here this z cosine 2x, and here e power minus 2y. So I can write this down. So then this minus will become plus. So now I can substitute the value. So I can put x as pi. You can see here cosine 2 pi, and y as 0, e power 2 0, and z as 3. So I can put this. So you know cosine 2 pi is 1, and e power 2 into 0, 2 into 0 is 1, so e power 0 is 1. So if I simplify, so it will be 3 over 1, and so the answer is 3. Now your homework is, so what you have to do from previous sheet, practice sheet number 3, you have to solve question number 6, part 2. So if you will solve part 2, so I will be very happy. And from practice sheet number 4, so you have to solve question 1, second part, fourth part, and seventh part. So because some parts I already solved, so the other parts you have to solve yourself. Now still there are some other challenging problem will come, because today we solve a very simple question where you just substitute the limit and you will get the answer. Only one question we have solved where you have to factorize or rationalize, or you have to do something. Otherwise all questions were very straightforward. So please try to solve one more time all these questions, And still, if you find any question, any problem in any question, so we will discuss in our online Moodle lecture. So during the lecture you can ask any question. I will be very happy to answer your question during my online lecture on Moodle. So thank you very much for watching this, and I hope you enjoyed the lecture. And please keep yourself safe, and try to solve all these questions, because most of the time if you are free, so you can solve these questions as many times as you like. And you can also watch, for example, if you have any confusion, you can watch again this whole video. So please keep up the good work, and take care of yourself and your family, and have a good time. Assalamu alaikum.